Hello everyone, welcome to Form 3 Mathematics. This is a part 1 video for chapter 6, Angles and Tangents of Circles. So in this chapter 6.1, we are going to look at angle at the circumference and the central angle subtended by an arc. So before you get confused by the title here, we try to do a bit of a revision regarding the terminologies that we are going to use regarding circles that you have learned before. So here we have a circle. So this dot in the center of the circle, we call this the center of a circle. And this line here, the outline of the circle, we call this the circumference. Then we have a line which connects the center of a circle to the circumference at a point here. So we call this a radius. Next, we have a straight line from one point of the circle to another point of the circle passing through the center of the circle. This line here, we call this a diameter. This must be a straight line. And we have another line where one point touches the circumference and another point touches the circumference, like for example this, but does not pass through the center of the circle. Other examples for this line here is like for example this. Okay, so this we call this a chord. Now this is a chord. This is a chord. Now if we have two radius connected like this, and from this point along this circumference, along this part of circumference until this point here, which is denoted by the blue line here, this we call this a minor arc. It is a minor arc because it is the smaller part compared to the bigger side here, which is represented by the green line. Okay, this green line here is what we call as a major arc. And then the area surrounded by these two radius and the minor arc, which is painted blue here, this area we call this minor sector. So I think you can guess that this area, we call this the green colored sector, we call this the major sector. So this is a very quick revision on the terminologies that you have learned. We continue. Now, angles at the circumference of a circle. So what is the angles at the circumference? Okay, so let's say you have a circle here, and then you draw a line, which is called a chord, and we connect another chord here, and we label this point here as A, this point here B, this point here C. Now this angle is called as angle ABC, written as this, angle ABC. And then from the point A to point C here, okay, this line, along this line, we call this an arc, the minor arc, and we can also write this as arc AC. It's a minor arc of AC, which is denoted by the blue line, the arc AC. So when we want to describe this angle, we can say that angle ABC, this angle here, which is angle ABC, is the angle at the circumference of the circle subtended by the arc AC. So this is how we describe this angle in this situation. Angle ABC is the angle at the circumference of the circle subtended by the arc AC. We try more examples. So now we have another two chords here, and then which forms an angle. So this angle here is called angle PQR. Okay, PQR. And this line from point P to point R, this line here, we call this an arc PR, minor arc PR. So angle PQR is the angle at the circumference of the circle subtended by the minor arc PR. This is how we use when we want to describe angles at the circumference. How about this? Can you describe the angles ABC? Okay, so angle ABC is the angle at the circumference of a circle subtended by the arc, by the minor arc AC. Okay, so ABC is the angle at the circumference of the circle subtended by the minor arc AC. Next example, PQR, the angle PQR is an angle at the circumference subtended by this arc. This time, this is a big arc compared to here. So this is a major arc, PR. Okay, so angle PQR is the angle at the circumference of the circle subtended by the major arc PR. R. Angle ABC, this angle here, is the angle at the circumference of a circle subtended by this arc. So this arc here is arc AC. This is a big arc, so it is a major arc AC. So the answer here, the angle ABC is the angle at the circumference of the circle subtended by the major arc AC. This is how you describe the angles at the circumference, which is subtended by the certain arc. And now we're done with the basics. We go to the next part. So before we look at the conclusion of next part, we try to look at this example. Here you are given a circle. You have an angle 30 degrees here, angle ABC, which is an angle at the circumference subtended by the minor arc AC. If I draw another line starting with point A to here, and I draw another chord here starting from point C here, and I label this as point D. And when I measure this angle here, ADC, this angle, I will find that this angle has the same value as this angle, which is 30 degrees. I measure this with a protractor. Then I try again. I draw another line, a green line here, starting from point A, and I draw another line starting from point C. And this touches another point on the circumference. So now I label this E and measure this angle here. I will find that it is also 30 degrees. So what conclusion can we get from here? Angles at the circumference subtended by the same arc are equal. Okay, so these three angles subtended by the same arc, which is arc AC. So any angles you form subtended by the same arc AC, they will have the same values. They are equal. This is the first property, and it is very important that you need to know. So we try to look at the examples. How can we use these properties? Before that, you need to note that for this angle here, this is not the angle at the circumference because this point does not touches the circumference. Thus, this angle does not equals to this angle. They are not equal. And one more is, if the point here is outside the circle, it's not on the circumference, it's outside here, this angle does not equals to this angle. So it must lies on any point on the circumference. Now, we look at an example. Given angle ADC is 25, angle ADC, the angles formed by the blue lines is 25. State the value of ABC, which is this, and angles AEC. AEC is this angle. So if you are confused with this, whenever an angle is written in this form, you look at the center point. D means the angle is formed at this point. Okay, ABC means the angle is formed at the vertex B, so this point. AEC means the angle is formed at E, which is this angle. Of course, if you apply the properties, since these three angles here are angles at the circumference, they touches the circumference, and they are subtended by the same minor arc. This angle, and this angle subtended by the same minor arc AC. Hence, this angle, and this angle here are equal. Since this is 25, angle ABC 25, angle AEC also 25. Example number 2, we have a slightly harder question. Calculate the value of the angle X. So we want to find X now. Okay, so you are given 35 and 25, which is angles at the circumference. So you need to use the information here. Okay, so now we take this the same diagram here. I draw this line yellow. I color this line yellow and this line so that you can see the difference here. Okay, the yellow line and the black line forms angles here and here, which is angles at the circumference of the circle subtended by the same arc. Okay, for the yellow line and the black line, they form angles subtended by the same arc here, the blue arc. Hence, we can say that these angles here is equal to this angle. So this angle is also 25 because this angle and this angle, they are subtended by the same blue colored line arc. So now we look at this pink line triangle. We learned before that the total angles in a triangle is 180. So if you want to find this angle, we take 180 minus 35 minus 25, you can find this angle. So 180 minus 35 minus 25 is 120. So we know that here is 120. And since this is a straight line, if you want to find x, you take 180 minus 120 here. Okay, so 180 minus this, you can find x. So 180 minus 120 is 60. Example number 3. Given the diagram where chord AD equals DF, okay, so AD equals DF, angle ABF equals to 32. Remember, ABF means you look at the B here, so ABF angles here, this is 32. CAD, angle CAD, D is here, sorry, CAD is 15, so it means this here is 15. Determine the values of all these angles. So since chord AD equals DF, so AD equals DF, so I note down here, okay, AD equals DF. So now we are going to use this information, this diagram here, to find all these angles. So the first one, AEF. AEF. So the angle is here. Okay, so you can see that AEF is the angle at the circumference of a circle subtended by the arc AF, this arc here. So you ignore the other lines. You only look at AEF and this arc. And then from the same arc, actually this is another angle here subtended by the same arc AF, which is the angle ABF, 32. So if ABF and AEF subtended by the same arc means this angle here equals to this angle. This is the first property that we learned. Hence, we say that angles AEF is 32 degrees. Next, question B. ADF is subtended. So the angle ADF actually is subtended by the same arc again, AF. So since ABF is 32 here, and this ADF subtended by the same arc, means this is also 32. So angle ADF is also 32. C. CFD. Okay, this time is this angle here. Okay, CFD. CFD is this angle here. So you can see that this angle is the angle at the circumference of a circle subtended by the arc CD. Okay, so this angle is subtended by this arc CD. And if we look at this side, there is another angle, which is this angle here. Okay, this angle is also subtended by the same arc CD. Okay, because of this line and this line, same arc CD. Hence, this angle here equals this angle, which is also 15. Hence, CFD is also 15. So now we go to question D, CAF. Okay, so CAF means we want to find 15 degrees here plus this angle. Okay, so this angle is DAF. So we want to find this angle plus 15, which is 15 plus angle DAF. Okay, so if we look at angle DAF, this is an angle from this orange triangle. DAF is from this triangle. And notice that this line and this line are the same. Hence, this is an isosceles triangle, meaning that the base angle here, this DAF, and this DFA, this angle here, they are equal, they are the same. If we know this angle, we can find the two angles Previously, in the previous question, we already find this angle which is equals to 32. Hence, to find these two angles, we get 180 minus 32 divide by this 2, divide by 2. So 180 because the total angles here is 180 minus 32 divide by 2 because these two is the same. So divide by 2, you get the answer is 89. So we move on to the next part where we learn the next property. So now we have a circle with an angle 25 degrees subtended, which is an angle at the circumference of the circle subtended by the arc PR, the minor arc PR, 3 centimeters. So now if we draw another line here, and this line, which forms an angle. So if we measure this arc here, we measure the arc which is 3 centimeter. Then when we measure these angles here, when we measure this angle, we find that it is also 25, same angles as the angles PQR. Okay, if we try again, now we try to draw another, form another angles with the arc which is the same as a 3 centimeter here, 3 centimeter here. Then we try to measure the angles here. We find that this is also 25. So from these two examples here, we can conclude that angles at the circumference subtended by arcs of the same length are equal. Okay, so when this arc here and this arc here has the same length, 3 centimeter, 3 centimeter, the angles subtended are the same. This arc, 3 centimeter, this arc, when they have the same length, the angles subtended by these two arcs, they will have the same value. They are equal. We try examples. Okay, so example number 1, determine the value of x. Okay, so x, the angle x is subtended by this arc, and the length of this arc is 5. And then when we have another arc, and then we have another angles here, subtended by arc which is also 5 centimeter. The length of the arc is 5 centimeter. So when the length of the arc is the same, the angles are the same. So x is 20 degrees. Example number 2. Given arc AC, so from A to C equals to B to D. So if this AC and BD are the same, the angles subtended by arc of the same length will be the same. Okay, so this angle is subtended by AC. This angle is subtended by BD. AC equal length to BD. They have the same length. Means this angle is equals to this angle. They are the same. So x is 27. Try a few more examples here. Okay, so this angle is 30 degrees. This angle is also 30 degrees. Okay, so this time we start with the angles. When the angles subtended by the arc are equal, this angle and this angle are equal, this means that the arc length here is equals to this, the arc length, because the angle is the same. So the arc length of this equals to arc length of this. Hence, x is 4.5 centimeters. So this is the first two properties you're going to learn regarding the angles at the circumference. So I'll see you in the next video where we learn more properties of angles at the circumference. That's all. Thank you, everyone. Hello everyone, welcome to Form 3 Mathematics, Chapter 6, Angles and Tangents of Circles. And in the previous video, we already looked at the first two properties of angles at the circumference. And this time we're going to look at the next two properties of angles at the circumference. So just a very quick revision. In the previous video, we learned that if we have two angles at the circumference of a circle, subtended by the same arc AC here, you'll find that the angles will have the same value. They are equal. So if we have another angle at the circumference of the circle, which is subtended by the same arc, the minor arc AC, we will know that this angle here will have the same value as all these angles, which is 30 degrees as well. Okay, so angles at the circumference subtended by the same arc are equal. That's the first property we learned in the previous video. The second property, we learned that angles at the circumference subtended by arcs of the same length are equal. So if the arc here, the arc PR is 3 centimeters, and this arc here is also 3 centimeters, then the angle subtended by these two arcs will have the same value, which is 25 degrees, 25 degrees. Same applies here. If this arc is 3 centimeters and we form another angle subtended by another arc which is 3 centimeters here, we will find that the angles, they have the same value. They are equal if the arc has the same length. And today we're going to continue with the next property here. So in this case, we have an angle at the circumference of the circle subtended by this arc 2 centimeters here. And if we form another angle with an arc length which is twice, double, 4 centimeters. Okay, you see this is 2, this is 4. We will discover that the angles formed here will also be double compared to this. 10 will become double, become 20. We try again with another example here. Still using this same part here. If we try to form another angle subtended by an arc which is now 6 centimeters. So 6 centimeters is 2 centimeters times 3. 6 centimeters here is triple the size of 2, because 2 times 3 is 6. We will find that the angles here will be 10 times 3 as well, which is 30 degrees. Now we try to form an angle subtended by the arc here, which is 10 centimeters. So 2 times 5 is 10, right? 2 times 5 is 10. So we will find that the angles here will be 10 degrees times 5, which is 50 degrees. So the conclusion we get from this is the size of an angle at the circumference subtended by an arc, so this size, the size of an angle, is proportional to the arc length. So maybe you're still a little bit blur on this. So how can we simplify this definition here so that it is easier for you when you want to do the calculations? So if we let this angle to be A and this angle subtended by this arc will be C, and we let this angle B and this angle subtended by the arc D, by using this definition we will get that B divided by A equals to D divided by C. Or if you want, you can take this angle here divided by this angle, A divided by B, equals to C divided by D. This is another way we can make use of this definition when it comes to calculations. Okay, so maybe you're still blurred with this. We try the examples. Example number 1. Determine the value of x. So given a circle here, when the angle subtended by an arc of 1.5 centimeter is 10 degrees, what is the value of the angle when it is subtended by an arc with 6 centimeters? So using this, okay, we can take x divided by 10 degrees equals to 6 centimeter divided by 1.5. Okay, so x divided by 10 equals to 6 divided by 1.5. Okay, then we just move the 10 here, you get this, calculate this, and you get the answer is 40 degrees. So if you want to understand why it is 40 degrees, you can see that when the arc is 1.5, the angle subtended by the arc is 10 degrees. So now when the arc is 6 centimeters, which is actually 4 times this, 1.5 times 4 is 6, right? So this is 4 times of this. Hence, we know that this angle will be 4 times bigger compared to 10 degrees. So x is equals to 4d. So 10 times 4 is 40. This is by using understanding. Determine the minor arc length of QR. Okay, so this time we have P as Q 45 degrees subtended by an arc of 9 centimeters, and Q as R is an angle of 15 degrees, and angles at the circumference of the circle subtended by the arc QR. So we want to find the minor arc length of QR here. So if we take QR divided by 9, it is equals to, QR divided by 9, it is equals to 15 degrees divided by 45 degrees. 15 degrees divided by 45 degrees. We've moved the 9 here, you calculate this, you get x equals to 3 centimeters. And again, if by using understanding, you can see that when the angle is 45 degrees, it is subtended by the arc 9 centimeters. So you see, when it is 15 degrees, 45 divided by 3, you get 15, hence 9 centimeters divided by 3, you get 3 centimeters here, which is 3 centimeters. Okay, this is by understanding. We'll go to the next example here. Given the length of minor arc AD, okay, so here we have AD, but the minor arc here, minor arc means from here along the circle here until here. Okay, this is the arc, minor arc AD. Is doubled the size of the minor arc BC. So BC is here. Okay, so AD is twice the size of BC. Determine the value of EAD. EAD means we are looking for this angle. So in order to find this angle, which is in a triangle, we need to find the other angles first in the triangle. Hence, we need to use this. You see the blue lines here forms an angle 20 degrees at the circumference of the circle subtended by the arc BC. So if we can use this to find the angle AED, then we can find this angle. Okay, now you see, so this angle here 20 degrees is subtended by the arc BC, and we know that AD is twice BC. So if we take the angle AED, divided by this angle BEC, the blue lines, which is as shown as this, AED divided by BEC, this is equals to the minor arc AD divided by the arc BC according to the properties. Okay, so the minor arc AD divided by the minor arc BC. And now we know BEC is 20, but this value is not given. But we know that AD is double the size of BC. So if BC is 1, AD will be 2. Right? In terms of the ratio. So it will be 2 over 1, which is 2 actually. I repeat, since AD is double the size of BC, when BC is 1 unit, if we consider BC as 1 unit, AD will be double the size, which is 2 units. So we can use 2 over 1 to represent the ratio of AD over BC. So we move 20 here, you get this, and you find the value of AED, which is 40. But this is not done yet because we only find AED, which is 40. We are still looking for this. Now, if we take away the blue lines here, you have this, and we just found that this is 40. So for this triangle, it is actually an isosceles triangle because this line and this line, they have equal length. So this angle and this angle, the base angle, will have the same value. They are equal. So if we take 180, the total of the interior angles, minus 40 divided by 2, because these two are equal, divided by 2, you can find the value. Okay, so 180, the total interior angles, minus 40, and divided by 2 because there are 2 base angles. You get 70 degrees, which is the answer. Now we go to the fourth properties here. Before that, we try to understand angles at the center of a circle. So when you see angles at the center of a circle, it means this. This angle formed from 2 radius here. We name this as the angle at the center of a circle. So after you understand this part, angles at the center of a circle, which is this, we continue. We form another angle at the circumference. This is angle at the center. This is angles at the circumference of a circle. When we try to measure these angles at the center, if we get 60 here, okay, and then we try to measure again the angles at the circumference, notice that they are both subtended by the same arc. So we found that this is 30 degrees. This angle here is 30 degrees. It's half of the value here. Okay, so we're not making any conclusions yet. We try again. So and this time we try to draw the line along this radius here. We form another angles at the circumference. This is a new example. When we measure this, let's say we get 50. And then when we measure this, we will find that this is 25, which is again half of the values at the angles at the center of the circle. Now we look at the third situation. Still angles at the center here. Now we form another angles at the circumference. Then we start by measuring these angles at the center. Let's say we get 100. And then we measure this, we'll get this 50, which is again half of the values of the angles at the center. Now the fourth situation, we draw this time, and this time we are measuring the angles at the center for the major sector. This is the major sector. Before we measure that, we draw a line here, we draw a line here, and now when we measure the angles at the center, let's say we get 240, and then when we measure this, we found that this is 120. Again, it is half of the angles at the center when the angle at the circumference subtended by the same arc as the angles at the center. So from these four situations, we can make a conclusion that the size of an angle at the center of a circle, here, this is the angles at the center, subtended by the same arc here, is twice the size of an angle at the circumference. This is the angle at the circumference. So in short, when the angles here are subtended by the same arc, they are from the same arc, the angles at the center of the circle is 2 times the angles of this. If this is 10, this will be 20. If this is 20, this will be 40. And if this is 100, here is 100, this is half of it, which is 50. We try to use this property to help us to solve the questions. So example number 1. Find the value of x. X is the angles subtended by the same arc with this. This is at the circumference, this is at the center. So we know that the one at the center is always 2 times bigger than this. So if this is 2 times bigger than this, means this is half the size. If you want to find x, this one divide by 2. 86 divided by 2, you get 43. Okay, always remember this one is half the size of this, and this is double the size of this. There we go to example number 2. Now you are given the angles at the circumference. You need to find the angles at the center. Okay, first you check they are both subtended by the same arc. So we know that this is double the size of this. Yeah, this is 2 times the size of this. So x equals to 2 times 35, which is 70 degrees. Example 3, find the value of a and b. So now we look at these angles here and these angles at the center here. Both of this angle, this and this, subtended by the same arc. So we know that this is double the size of this. A is twice the angles of 25. So A equals to 2 times 25, which is 50 degrees. And now we look at B again. We have this, and this. So this angle here and this angle here are both subtended by the same arc. Hence, this is the first property we learn. B is equals to the value of 25 because both of these angles at the circumference, they are subtended by the same arc. So B equals to 25. I forget to mention that we usually use O to label the center of the circle. So this point here, the center of the circle, we label it as O. Example 4, okay, this is the center of the circle, which should be labeled O, but I forget, never mind. Now we look at the question is it asks us to find the value of A and B. So A and B. So actually one of the common mistake that students make is they thought B is half of 110. No, actually you should consider, you see the angle B is subtended by this major arc. So if you want to find B, you need to find the angles here from these two lines, which is from this major, which is subtended by the major arc as well. So if you want to find B, you need to find A first. Okay, because B is half the size of A, not the 110. Be careful here. So now, if you want to find the A, so 110, the angles here, and the angles A here, they form the angles of a whole turn, which has a total of 360. Okay, 360, we learned this in Form 1. So A equals to 360 minus 110, which you get 250. So if you get 250 for A, so we know that B is half the size of A because of the properties that we just learned. So B equals to 250 divided by 2, which is 125. Go to question 5. Example 5. Find the values of x and y. So x is the angles at the center. Y is from this line, the radius here, until this line. So first thing, we look at these angles when 32 is subtended by this arc until here, this arc. And you'll find that angle x is the angle at the center subtended by the same arc with this angle compared to this angle. They are from the same arc. Hence, from the properties, we know that this is double the size of this. 32 times 2, you get 64. Now, for y, so in order to find y, you can see that this is actually a triangle. And then, since this is a center of a circle, means this line and this line here, they are the radius, and they have the same length. This means that this is an isosceles triangle. Then, so this angle here is the same as the angle y. So in order to find this, we take 180, which is the total angles of this triangle, minus x, which is 64. And then, since the two base angles are the same, you divide by 2. So this is 180 minus x, minus 64, divided by 2. Okay, to find y, which is 58 degrees. We go to example 6. Diagram shows a circle with center O. Again, we have an O as a center. Determine the value of RST. RST, we want to find this angle. QPU. QPU, this angle. PQT. PQT, this angle. So we try to settle this one by one. We try to look at RST first. Okay, so in order to find RST, which this angle here, and this angle is formed from the line RS and ST. So actually this is an angle at the circumference of a circle subtended by the major arc RT. Okay, so this angle is subtended by the major arc RT here. There is another angle subtended by this arc. So now I'm going to draw the red lines here. Okay, so for this angle again, this angle subtended by the arc RT, and this angle here from this side, this from here to here, this is the angle subtended by the major arc RT as well. Okay, so this angle here is half the size of this angle here. Because this angle and this angle here are both subtended by the same arc, which is RT. They are from the subtended by the same arc. So if we can find this angle, if we can find this angle, we know that this is half of this angle. So now how are we going to find this angle here? Again, this is an angle of one whole turn. So you take 360 minus 120. 360 minus 120, you get 240. So meaning that from here to here is 240. So if we know that this is 240, this angle is half of this 240 here. So you take RC is 240 divided by 2, since it is half. So you get 120. Next question, QPU. QPU. So this time we are looking for this angle here, QPU. So you can see that this angle here is subtended by the arc QR. Yeah, this angle is subtended by the minor arc QR. And from this same arc, actually there is another angle here. This angles at the center here is subtended by the same arc QR, yeah, formed from this line. So meaning that if we can find this angle, the value of this, we can find this, because since this is an angle at the center, this will be half of this. Okay, this is half of this from the properties that we've learned. So I think it's quite obvious how to find this angle. You see this line is a straight line. So angles on the straight line is 180, meaning that 180 minus 120, you can find this. 180 minus 120, you get 60, meaning that here this is 60. So if we know that this is 60, this is half here. This is half of 60, which is 30 degrees. So for the last one, we want to find angle PQT. So since we already know that this is 30 from question B, I'll leave it here. Okay, to find PQT is actually to find this angle PQT. And you notice that this is a triangle. So if we can find this, 180 minus 30 and minus this, you can find PQT. So in order to find this angle here, this is a straight line. So 180 minus 105, you can find this. Okay, so 180 minus 105, you get 75, meaning that this is 75. So if you get 180 minus 30 minus 75, you can find this angle PQT, which is also 75 degrees. So in the next video, we're going to look at the rest of the properties of angles at the circumference. So I'll see you in the next video. Thank you.
Hitung nilai Z. Jadi kita tahu kalau dia lekuk yang sama, nampak tak satu lekuk, dia tarik pergi tempat yang berbeza, asalkan dia dari satu lekuk yang sama, dia punya sudut adalah sama. Jadi Z sama dengan 35. Sebab sudut sini nampak, tarik pergi sini dapat 35, tarik pergi sini pun patut dapat 35. Okey, macam ni nampak tak? Dia kongsi sudut yang sama. Sudut yang sama tarik pergi dapat 25. Jadi lengkuk yang sama tarik sini dapat 25. Okey, macam yang ni kan nampak? Lengkuk ni, Z ni dekat lengkuk ni. Bila tarik sini dapat lengkuk Z. Bila tarik sini, sini pun patut dapat Z. Nampak tak? Dia tarik lengkuk yang sama. Okey. Lepas tu kita tengok. Lepas tu kita tengok sini 80. Bila sini 80? Bila sini 80, garis luruskan 180. Jadi sini adalah 108 nama. Jadi sini adalah 180 tolak 80 sama dengan 100. Jadi sini adalah 100. Kita tahu kalau segitiga sama dengan 180 darjah. Jadi Z tambah 100 tambah 50 sama dengan 180. Z sama dengan 180 tolak 100 tolak 50. Jadi dapat 30. Jadi sini Z sama dengan 30. Sekarang ni tengok tak? Ni Z kan? Nampak tak? Lengkuk dia buat macam ni. Lengkuk yang sama tarik pergi sini. Jadi sini sama dengan Z. Kita tengok sini, sini sama. Nampak tak? Bila sama, sudut dekat sini sama dengan sudut dekat sini. Jadi Z dekat sini, sini pun Z juga. Dan kita nampak garis lurus sini ada 70. Jadi sebelah dia adalah 180 tolak 70 bersamaan dengan 110. Jadi kita tahu dua sudut ni sama. Satu segitiga sama dengan 180. Jadi Z tambah Z, Z tambah Z tambah 110 sama dengan 180. 2Z sama dengan 180 tolak 110 sama dengan 70. Jadi Z sama dengan 70 bahagi 2 sama dengan 35. Jadi Z sama dengan 35.